The academic journey is one that is essential to our being here in KNUST. Next week, we will sit for the mid-semester exams. My team and I have compiled this video tutorial to help you navigate topics that are hard to understand. My name is Bernard Busmayeboa, popularly known as BBY, and I wish you the very best in the upcoming mid-semester.
We are going to talk about statistics, and then we begin with the introduction to statistics. So statistics is a science of collecting, analyzing, and interpreting data. So when you go to the field, you gather data. You come there and do your analysis using statistical softwares like R, MATLAB, Stata, SPSS, and others. You analyze the results and then you now interpret. We have two main types of statistics, which is the descriptive statistics and inferential statistics. With the descriptive statistics, it's all about organizing and summarizing the data using numbers, graphs like histogram, pie charts, bar graph, line graph, dot plot, among others. And then you can also describe the data using graphs to tell if it is symmetric, whether it is skewed left or skewed right, positive or negative. And then using histogram or using ketosis or thickness. We can also describe the data using measures of central tendency. And then with the measures of central tendency, we have the mean, the median, and then the mode. These are the three ends for measuring the central tendency. So all I spoke about can be found here. These are the types of statistics. We just spoke about the descriptive, and then with the inferential statistics, we make inference. Here, this is where you just analyze the data. Here, you make analysis. You just don't describe the data. So after making analysis with a sample, you make inference about it with the population. So after probably saying that with a sample, let's say 20% of students study nursing, you can say then we're using a sample of 100, 20% study nursing. Then we can use that to make inference that with the whole population, 20% study nursing. So if the population is 50,000, you can say 20% of the population study nursing. So we are going to talk about some basic terms, which are the basic terminologies, which are the individual, variable, population, parameter, sample, and statistic, with the abbreviation IVPPSS. So what is our individual? Our individual is the unit which we are interested in our research, a unit of interest in our research. That is the individual. Then the variable is the characteristic of the unit of research we are interested in. Then our first P is our population. What is our population? It's every single variable or every single individual which is in the research interest. And then our parameter is a number or something we use to symbolize the population. So if you take population, a parameter can be mu. We know mu is the symbol like the U with a longer bar beneath it. And then we have the sample. With the sample, it is just a subset or a part of the population. So you want to do a research and then you want your population to be the whole Ghana. You can't count every individual and use it for that particular research. So you take a sample. The sample can be maybe people in Kumasi, or you take a proportion from Accra, Kumasi, Sunyani, and other regions, and that represents the population of Ghana, and use it as your research. So with that, the number we use in representing the sample is the statistic. And the statistic, that is something, an example of the statistics which represents the sample is the X with the bar on top. And then for the variance, we have the small s. So this is what I spoke about the IVPTSS. We then go ahead to learn the types of variables. So we have two main types of variables, which is the qualitative and the quantitative. So when you hear quantity, what comes in mind? Measurement. So it's all about numbers. We can count. Count anything that can be counted is quantitative. So what can we count? We can count number of wives, we can count number of shoes, we can count everything we count is under quantitative. So under the quantitative, we also have the discrete and then the continuous. So discrete are exact values like 1, 2, 8. So 8 cars, 4 shoes, 6 slippers. They are discrete. And then for continuous, when you take 2 points, within that 2 points, they are individual and they are within that 2 points, there are continuous numbers. So when you take 1 and 2, we all know if it's discrete from 1, you go to 2. But you can't say you have 1.5 leg or you have 1.5 shoe. It's not possible. It's either you have 2 pairs of shoes or you have 2 books. You can't say I have 1.5 book. So for the continuous, we have examples like weight. Weight, we can say you are probably 50.6. And then for height, we can say probably you are 1.7 meters or centimeters. And then temperature, we know probably 36 point something. So with the decimals that comes in there, that makes it different from the discrete. With the discrete, you can't have decimals. They're exact values. They are whole numbers or counting numbers. But with the continuous, they are, as the name says, continuous. So there are decimals within them. Then the second type of variable is the qualitative. So under the qualitative, it's just describing. It's all about describing the script. So you can just keep this in mind as there are 5 sense of impulse. So we can touch. What we can touch, we cannot count. We can feel. What we can feel, we cannot count. So what we can taste, we cannot count. What we can hear, we cannot count. So probably you can say you can see. You can see the eye color of someone, but you can't count the eye color of someone. So it's qualitative, but we know we have eye colors like blue, brown, black. We have gender, we have marital status. We can't count them. Educational level, we can't count them, but they are qualitative. So under the qualitative, we have 2 types, which are the nominal or categorical. And then we have the ordinal. So let me start with the ordinal. With the ordinal, it's as the name says, it's in order. It's in order. So ordinal here means it's in order. You don't go to one step without going to the other. So you can't tell me that you came to university before you went to primary 6, or you wrote your university exams, you got your first degree before you got your BC degree, before you went to get your SHS certificate. It's not possible. It's an oddly something. So from class 1 to class 2, class 3, and then probably you were single, you got married before you got divorced. It's an order. You can't say you were single, you got divorced before you got married. It's not possible that. So that is for the order. Like ranking positions in the military, there are ranks which is in order. Sometimes depends on your educational level, depends on your hard work and everything. We have for the nominal or the categorical. As we said, it's categorical. There is no ranking. It's there's no ranking, there's no order. So it's just like gender. You can't say male come before females or female come before males. There's no order. Eye color, you can't say color eye blue, red, black comes before one comes before the other. So it's comes in any order at all. That's for the nominal. Yeah. Then, so this is for the nominal and then the ordinal. And then so this is a whole summary of the variables. So as we can see, the two types of variable is the qualitative, quantitative. And then the qualitative, quantitative, we have nominal and ordinal. And then the nominal and ordinal. And then we go to the quantitative. And the quantitative, we have discrete and continuous. So we continue with the descriptive data analysis. So yeah, this is where you can hear all the measures in the world. There are all the measures in the world are probably talking about doing the analysis. So you can hear measure of central tendency, measure of position, measure of dispersion, measure of variability, measure of spread. All the measures are here. So another measure of central tendency. Under the measure of central tendency, we have the mean, the median, and then the mode. We have the mean, the median, and then the mode. So now the arithmetic mean, it's the normal mean we all know. We sum all the data points. So probably 2 plus 3 plus 4 plus 5 plus 6 over the n. So probably, and I have an example. Let's say we are summing 2 plus 5 plus 8 plus 11 plus 14 plus 17 plus 18. This is 7 data points. So we sum all this and divide by 7 and we get our mean. So the normal mean we hear is also known as arithmetic. Then we go ahead with the geometric mean. So I don't if you've heard geometric sequence in senior high school, it's more or less like the geometric mean. It's a sequence. So here we have the common ratio. Under the arithmetic, we have the common difference. So under the geometric mean, you actually take the square root of, if you are finding the mean for just 2 data points, you take the square root of the 2 data points. So let's say you have 2 and you have 8. So you take the square root of 2 and multiply it by 8. You get what? 16. Square root of 16 is 4. And that will be your mean. But if it's more than 2, it's you sum all. So if it's more than 3, you can sum all, like the initial example I gave. 2 plus 5 plus 8 plus 11 plus 14, 17 plus 20. And then you put all into brackets and raise it to the power 1 over n. So here our n is 7. So if we sum 2 plus, or if we add 2 plus 5 plus 8 plus 11 plus 14 plus 17 plus 20, and raise all to the power 1 over 7, we will get 24, and that will be our geometric mean. But square root is the same as any number raised to the power half, which is 1 over 2. So getting the square root of 2 data points, let's say a and b, is also equal to a square bracket a, b, all raised to the power 1 over 2. That's for geometric mean. And then we go ahead with the weighted mean. With the weighted mean, we have the sum of the individual weights multiplying the data points all over the sum of the individual weights. So let's say you have a sodium chloride of 30% concentration and a volume of 180 ml. That's for the first one. And then you have a second one, let's say this the same concentration, sodium chloride concentration of 50% with volume of 120 ml. When you sum the volumes, which is 180 ml and then 120 ml, you get 300 ml. So here in finding the weight, we do it, you can write as I speak, C1 multiplied by V1 plus C2 multiplied by V2 all over V1 plus V2, where our C1 is 0.3, which is 30%. Our C2 is 0.5, which is 50%. Our V1 is 180 ml, and then our V2 is 120 ml. So in fixing this into the formula, is 0.3 times 180 plus 0.5 times 120 all over 180 plus 120. So for the numerator, you will get 114 over 300, and then you will get 0.38, and that will be your weighted mean. It's mostly in percentage or proportion. That's for the weighted mean. And then look at the last one, which is the harmonic mean. So with the harmonic mean, it is the sum of the reciprocal of the x values divided by the observations. So all this English means that you sum the reciprocal. Reciprocal is probably just 1 over your data point, 1 over the number you have. So if with the example above, which was 1 over, which was 2, 5, 8, 11, 14, 17, and 20, we take 1 over each of the numbers and then sum them. So we have 1 over 2 plus 1 over 5 plus 1 over 8 plus 1 over 11 plus 1 over 14 plus 1 over 17 plus 1 over 20 all over 7. And then you put a big square bracket around it and then raise it to the power -1. So, or an alternative formula is n over summation of 1 over the x values. So you can do n, which is 7 all over into bracket. Here you don't do 1 over 2. You will get it wrong. You do 1 over 1 over 2 plus 1 over, then there you can put the denominator 1 over 5 plus 1 over brackets open 1 over 8 plus 1 over brackets open 1 over 11 close the bracket plus. So you do it for the denominator for all the values, and then you get your answer. Or you can still do it n over the normal 1 over x, 1 over x, and then you put only the denominator into brackets and raise it to the power -1. So that is it for the harmonic mean. This is arithmetic mean. So the population mean, we have two types of mean, two main types of mean, which is the population mean and the sample mean. Population mean here is represented by mu, as I said earlier, the u with a long bar beneath it. And then it is the sum of all the data points over the population. Population is represented with a number big N. Sample mean is the same thing, but represented with small n. And then here, the mu is represented with x bar, but you still sum the data points. Then, as I said earlier, sample is a part or a subset of the population. So we have an example here. So with the grouped data, finding the mean of a group data, here we can see that you have the class limit. Here the class limits can be, this is class limits. You can have grade, you can have marks or anything. Then you have the frequency. So mostly you just be giving these two. You have to find the midpoint and you have to find the cumulative frequency. Yeah, this is the cumulative frequency. No, this is midpoint multiplied by frequency. You can find the cumulative frequency as well. That is only if you are finding the median. So here, with the class limits, we have the lower bound and the upper bound. So here the lower bound is 6, the upper bound is 10. So you sum the two and divide by 2. So 6 plus 10 divided by 2. 6 plus 10 is 16 divided by 2, you get what? 8. 11 plus 15 is 26 divided by 2, you get 13. 16 plus 20 is 36 divided by 2, you get 18. And then you continue that way. So when you get the midpoint, that now becomes your x. You multiply this by the frequency, and then you get the fx. So when you sum the fx and divide by the total number of ends, here we have what? The frequency 1 plus 2 is 6. 6 plus 5, 11. 11 plus 4 is 15. 15 plus 3 is 18. 18 plus 2 is 2. Then that will be your end. Then you get your mean. So if you want your median, you only include the relative. Then the cumulative is just adding up the frequency. So like 1 here, then 1 plus 2, you get what? 3. 3 plus 3, you get what? 6. 6 plus 5, you get what? 11. 11 plus 4, you get what? 15. 15 plus 3, 18. 18 plus 2, 20. So that one, we don't have anything like the summation. It ends that at that end. End there. And then so with the median, the value for the last value, which is 20, divided by 2 is what? 10. But here we can see that 6 is less than 10 and 11 is greater than 10. But from 6, so from 6, we know we have 7, 8, 9, 10. So from 7, 8, 9, 10 to 11 can be found within this range, which is 21 to 25. So our median is 11. And so our median is actually not 11. This is the class limit, 21 to 25. And then the mode is the highest frequency. So when we look at this place, the highest frequency is what? 5. So when you come, the mode is still 21 to 25. We then go ahead to look at the measure of spread or measure of dispersion or measure of variability. So if you've heard any of these names, it still comes to the same thing. And the measure of spread or dispersion, we know dispersion is the same as spread. And then when you're spreading something, you are probably finding the difference of it, which makes it more variable, finding the variance. So we have the range, we have the standard deviation, we have the variance, and then we have this three: the range, the variance, and the standard deviation. So finding the range is just getting the highest value and subtracting the smallest value from it. And that's what the answer you get is the range. So here we can see that the highest value is what? 22.1. The least value is negative 8.1. And then we have 30.2. We know with negative values, the bigger the number, the smaller it is for negative values. So this is the range. That's all for range. With the mean deviation, it is how the mean is, how the value here is far away from the true mean. So if you don't take absolute of it, you will get 0. If you forget to take absolute of it, you get your numerator to be 0. And any number, 0 divided by any number is 0. So you get 0. So you always have to take absolute of it. Otherwise, you always get 0. So if you have 2, 5, 8, 11, 14, 17, 20, the mean here is, we computed for the mean, and we had 11. So it's going to be 2 absolute of 2. Absolute here means any negative value still remains positive. So 2 minus 11 is 9, negative 9. But you don't write negative 9, you write positive 9. So that's all absolute here means. Any negative value still remains positive. So that is it here. We have the variance. The variance also, this is the population variance, which is the data point minus the population mean squared. So the difference here is it's a squared, and then we divide by the number of data points or number of observations. The sample variance is the same thing, but here the n is -1. Here the n is -1. Please take notes. Standard deviation is simply taking the square roots of the variance. So when the variance is always squared, when you take the square root of the variance, it means you've taken off the squared, and then you get the standard deviation. So it's always good to find the standard deviation, the variance before you find the standard deviation. Then when we come to the coefficients of variation, it's just the standard deviation over the mean. Yeah, the standard deviation over the mean. And then if you want it in percentage wise, you multiply by 100, then you get it. We come to the measure of position. Under the measure of position, we have 3 things. We have the quartile, we have the decile, and then the percentile. Under the quartile, it's dividing whatever you have into 4 equal parts. The underlined word here is equal. We divide it into 4 equal parts. So here we can see 25%, 25%, 25%, 25%. So the first quartile is just 25%. When you add 25 to 25, you get what? 50. So the second quartile is 50%. When you add 25 to 25 to 25, you get what? 75. So the third quartile is 75. That is how we have the first quartile to be 25, second to be 50, and then the third to be 75. So the first quartile, which is Q1, is also the same as the 25th percentile, which is P subscript 25. And it's also this, yes. Then the second quartile, Q2, is also the same as the median. It's also the same as the 50th percentile. And it's also the same as the 5th decile, which is D subscript 5. So, and then the third quartile is the same as the 75th percentile. So we can see here what I said earlier here. Then with the percentile, we have with the decile here, dividing it into 10 equal parts. Dividing it into 10 equal parts. And then with the percentile is dividing it into 100 equal parts. So to find the position of a percentile, the simple formula to use here is K over 100 plus, K over 100 brackets open N plus 1. N here is the number of data points. N here is the number of data points. So if you are finding, let's say, L25, which is the location, whatever you get is not the value, it is the position of the value. So you go and look for that position, starting from your left to your right. You count first, second, third. So if you get 10, the 10th position, the 10th value is the actual value for the percentile. But whatever you get from the formula I quoted earlier is the position. So here they are saying find the 10th, 45th, and 90th percentile. So with the 10th, it is L10 is equal to 10 over 100 multiplied by our n here is what? 1, 2. Our n here is 40. So multiplied by 40 plus 1. we get 4.1. We don't have 4.1 as a position. Position, we know it's first, second, third. We don't have any 4.1. But we know this 3 here is the first, this is the second, this is the third, and this is the fourth. But 4.1 is between this and this. So we take the two values and sum them and divide by 2. So 12 plus 5 divided by 2. You get 8.5. And that is the 10th position. 12, you get that's the 10, that's the value right. With the 8.5, we can see it's between this and this. We go to our last topic, which is the measure of shape. Measure of shape is just two things. It's about the ketosis and then the skewness. With the skewness, we have three things. We have symmetrically skewed, positively skewed, or right skewed, and then negatively skewed or left skewed. So when this is the tail, this is the tail. When the tail is going to the right, it is right skewed or positive skewed. When the tail is going to the left, it is left skewed. But when it is in the middle like this, it is symmetric. To find the coefficients of the skewness, it is 3 times the mean minus the median all over the standard deviation. That is how to find the skewness, the coefficients of skewness. And then with the ketosis, yes, so there's the normal distribution is only symmetric when the mean, median, and mode are the same. So when they are the same, it's here in the middle at this place. That is when it is symmetric. When the tail is to the left, it is left skewed or negatively skewed. The mean is here. The median is somewhere here, and then the mode is the topmost. Yes, the highest point. So here we can see that the mean is less than the median, and the median is also less than the mode. And then when it is right skewed, the mean is greater than the median is greater than the mode. This is an example of the ketosis, the skewness. When we come to the peakness or the ketosis, so here the name says it's the peakness. So it's either it's peaked or it is flat, yes, or it is normal. And then here to find the ketosis, it is half of the third quartile minus the first quartile over the 90th percentile over minus the 10th percentile. And then if the ketosis is equal to 3, it is symmetric or it is normal. If it is less than 3, it is less skewed. Yeah, and if it is greater than 3, it is more peaked. So this is a graph showing it. So here it's less than 3. We can see how it's moving. So it's going to the top. And then it is flat. But you see here, it is greater than 3. See how high it is getting. And then for here, it is normal. You see, it's not really peaked. It's not really flat. Since it's less than 3, you see, it's getting flatter. This is an example can solve. Then we come to the 5-number summary and box plots. So as it says, 5-number summary. So you need 5 things. Only there's 5 things. If you don't even have one of them, it's not possible to get your box plots. So you need first your minimum value, second your first quartile, third your median, then your third quartile, and then lastly your maximum value. So in drawing the box plots, this whisker. This thing is called whisker. And then this is the box. Your whisker, the first bar here, it is the minimum value. The last bar here is your maximum value. This box here, the first bar of the box here is your first quarter. The second one here is your median or your second quarter or your 50th percentile. And then the last one here is your third quarter or your 75th percentile. So that is how to draw the box plots. So any number, given any value. So here our highest value is what? 0. Our lowest value is 0. Highest value is what? 27. And then how do we find the first quartile? The median. The median, we have how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So with 11 values, we know when we take the first 5 off and then the last 5 off, we get this middle number, which is 3 as our median. Now we take the median away and deal with these 5 numbers. With these 5 numbers, the middle number is 2. And then with the last 5 numbers, the middle number here is what? 5. So in drawing our box plot, we get our first whisker, our minimum value to be 0. Then we do the bar. It's like a number line. So the number line from 0 to 2, you get your bar there. Then from 2 to 3, then from 3 to what? 5. Then now you go all the way to 27 to get your maximum. And that is your box plot. So with the box plot, when the whisker, you can use the whisker or the plot. When the whisker on the right is longer, it is right skewed. If this whisker was longer here, it would have been left skewed, or the box. If the box is bigger, it can be, if the box is bigger on the right, it's right skewed. If the box is bigger on the left, it's left skewed. So that's how you interpret the box plot. So you are comparing the skewness to the box plot. So you can see this is left skewed. And then looking at the whisker and then the box, you can see the box plot is also left skewed. You can see here it's equal with the whisker and the box. And then it's equal here. So it is symmetric or it is normal. Then here it is right skewed with the tail and it is right skewed with the whisker. Yeah. Thank you. So this is it's left with the last one. Probability.
Meeting overall how many slides? Which slide?
Oh, this is slow.
Where 20 slides?
20. Say. Meaning, so with there is the last section, and then in here we talk about the probability. So what's probability? Probability is the chances of getting something. So it's a 50-50 something. We can't say it's deterministic or something. It's random. Yes. So with weed, we have an experiment. And then in an experiment, it's either it's deterministic or it is random. So the experiment being deterministic means we already know the outcome we are going to get doing the experiment. Random means we don't know what we are going to get. So like writing an exam, you don't know your score. It's random. Yeah. So an experiment simply means a repeated process with a well-defined possible. The word here is possible outcome or result. And then what are outcome? Outcome is the result of something. So you take a quiz, the outcome is your marks. That's your result. Then we have the sample space. What's a sample space? A sample space is all the possible values of an experiment. So every single possible value we'll be using in the experiment is the sample space. And then an event, sample space is mostly represented with the letter S. And then an event here is a part of a sample space or a subset of a sample space. So a sample space is always bigger than an event. And an event is represented with the letter A. So we mentioned earlier, an event is represented with the letter A. So we have these are operations. We have the union and then the intersection. Those you can also call them compound events. So those are the most important operations we use, the union and then the intersection. The U is the union and N is intersection. So A prime or A bar or A small c here means complement. So here they're saying denote the event which occurs only if the event A does not occur. So when we say event A does not occur, anytime you hear not, you use either A bar or A prime. So this is a possible probability of an event occurring. So probability of an event occurring is the event A over the sample space. We have axioms. So axioms are already defined theories. It's something that you can't prove it. You can't argue about it. Like someone telling you that your mom is older than you. You can't prove that you are older than your mom. And there's no need to prove that your mom is older than you because it is already there. It's already defined that your mom is older than you. So in probability, we also have axioms where we don't need to prove them. They're already defined. So here we know a probability of an event is always between 0 and 1. Then the probability of a sample space is always equal to what? 1. A sure event is always 1. And the last one, there's summation of all the events in a sample space also adds up to 1. So here we have, as I said earlier, the compound events or the combined events. We have this here means the event is the union of the events. So with the union of the events, we have A union B, which is the probability of events A occurring plus events B occurring, minus the probability that events A and B will occur. So events A and B will occur is also equal to events B and A occurring. And then we have the probability of event A occurring here as probability of A intersection B plus probability of A intersection B complement. This is an example. They are saying calculate probability A will occur where I is greater than or equal to 2. So greater than or equal to 2 means you start from here. Then you sum all this up and divide by the total probability, which is all this. So you sum from here 0.25, 0.3, 0.55, 0.25, all over this same term plus 0.05. Summing all this in a sample space and summing from here to here is just probability. Event A. And then with event B, they are saying that where I is less than or equal to 5, but where I is less than 5 but greater than or equal to 1. I being less than 5 means 4. Greater than or equal to 1 here starts from here. So it means you sum from E1 to E4 and divide E1 to E4 and divide by E1 to E5, the sum of E1 to E5. And then for C, where I is greater than or equal to 3. So I being greater than or equal to 3 means we start from E3 to E5 and sum and divide by E1 to E5. Yeah. With the example 2. So So I believe with the previous explanations, you can do example 2 on your own. A complement simply means 1 minus probability of A. B means B complement means 1 minus probability of B. And then that's how it's done. And then we have mutually exclusive. So mutually exclusive means there is no intersection. There is no intersection. Yes, that's all about mutually exclusive. That's why A intersection B is equal to 0. And then we have this example here on mutually exclusive. So since they are saying A and B are mutually exclusive, automatically B is 0 because there is no intersection. But if they said they are independent, then you would have said probability of A multiplied by probability of B. That's the difference between intersection and mutually exclusive. So this is for independent. This is conditional probability. So with a conditional, it's always a condition giving something to happen. So before something will occur, it means something has triggered it. Something has already occurred. So probability that B giving A means B giving A means B before B will occur, A has to occur first. And that is the breakdown of it here. These are all under conditional probability rules you are supposed to know in order to solve probability problems. And this is an example under the